A Chinese EV can pull into a station and leave with a fresh battery in minutes. It rolls onto a platform in China. The driver stays seated. Cameras read the car. The floor lines it up, and machinery under the vehicle reaches for the battery pack, like a pit crew working under the road. Then the heavy pack drops out from below. A charged pack slides back into the same space. The bolts lock. The system checks the connection. The car drives away without waiting beside a cable, without hunting for a charger, and without adding half an hour to the trip. This is not a concept. NIO has built automated battery swap stations across China, and the target is obvious. It is aimed at the one advantage gas stations still have over electric cars: speed. The headline is not faster charging. The headline is that China found a way around charging altogether. For more than a century, the gas station owned the strongest habit in transportation. You pulled in, chose a pump, filled the tank, paid, and left. The machine was dirty, noisy, and tied to oil, but the routine worked. In America, that routine became part of the road itself. That is the benchmark EVs have been chasing. A gasoline car does not ask you to study a charging curve. It does not ask whether the charger is working, whether another driver is blocking the stall, whether the battery is too cold, or whether the last 20% will slow down to a crawl. The gas station wins because it is fast, familiar, and almost everywhere. Electric cars changed the vehicle. They still have not fully replaced the refill habit. That is what makes battery swapping dangerous to the old model. It treats the battery less like a permanent organ inside the car and more like a removable energy cartridge. The vehicle arrives with an empty cartridge. The station gives it a full one. The driver does not wait for electrons to move through a cable at highway speed. That sounds simple.
It is not. To see why it matters, start with the weakness every charging network has been trying to hide. Even very fast charging still makes the driver participate in the wait. On paper, modern fast chargers look strong. A good EV at a strong charger can add meaningful highway range in 20 to 40 minutes. For many drivers, that is enough. You get coffee, use the restroom, check messages, and the car is ready for the next leg. But the road does not run on perfect examples. A holiday weekend changes the math. One charger goes down. Another is occupied by a car charging from 80 to 100%, where the battery takes power more slowly. A third has a payment problem. A fourth is working, but at reduced output. Suddenly, a 25-minute stop becomes 50 minutes, then an hour, then a line of drivers staring at dashboards. Gasoline built its reputation by avoiding that feeling. The old 5-minute refill is powerful because it is predictable.
A family on a road trip does not have to calculate battery temperature or charging speed. A contractor does not have to gamble with a workday. A driver in an apartment building does not have to hope the landlord installed enough chargers in the garage. That last group matters. Home charging is the quiet advantage behind many EV success stories. If you own a house with a driveway, an electric car can feel easier than gasoline. You plug in at night. You wake up with range. The gas station disappears from daily life. But millions of drivers do not have that setup. They park on streets, in shared garages, beside apartment towers, or near workplaces where chargers are limited. For them, the EV promise can still mean planning around infrastructure someone else controls. And then there is battery aging. Fast charging does not automatically ruin a battery. Modern packs are engineered with cooling systems, software limits, and chemistry choices that protect them. But drivers still worry. They hear that heat matters. They hear that repeated fast charging can add stress. They see the battery as the most expensive part of the car. That fear creates an opening. NIO looked at the problem from a different angle. Instead of asking every driver to wait while the battery filled, the company designed cars that could hand the battery to the station. The vehicle waits for the pack. The driver does not wait for the charging process. NIO put its first battery swap stations into service in 2018, then built the network around a very Chinese problem: long-distance travel at huge scale. Expressways mattered early because highway anxiety is where charging fear becomes most visible. A city driver can return home. a road trip driver needs confidence at the next stop. The idea was almost upside down compared with the American EV story. In the United States, the focus went to bigger batteries and faster plugs. NIO's answer was to make the battery removable and build stations where the exchange could happen automatically. From outside, it looks like a box beside the road. Under the floor, it changes the whole car. A NIO power swap station works because the vehicle, the battery, the software, and the station are designed as one system. The driver does not pull up to a random machine and hope the plug fits. The car knows the station. The station knows the car. A typical swap begins before the battery moves. The system identifies the vehicle. The driver chooses the service through the car's screen or app. The station checks the vehicle type, the pack, and the available inventory inside the building. Then the car moves into position. In newer stations, the process can feel almost like entering an automatic car wash, except the machine is not cleaning paint. It is preparing to remove the most valuable component in the vehicle. The car rolls onto the platform. Sensors and cameras align it. The floor system helps place the chassis within a tight operating window. That precision matters because the battery pack is not a suitcase. It can weigh hundreds of kilograms. It sits flat under the cabin, forming part of the vehicle's structure and weight balance. If a robotic system is off by a small amount, that is more than an inconvenience. It is a mechanical problem. Once the car is aligned, the station raises or supports the vehicle and reaches the pack from below. Automated tools locate the mounting points. Bolts are removed in sequence. The depleted pack is lowered out of the floor of the car and moved into the station's internal storage area. A fresh pack arrives from the station inventory. It slides into place from underneath. The same robotic system lifts it into the chassis, aligns the connection, tightens the bolts, and runs electrical checks before the vehicle is cleared to leave. Only after the system confirms that the pack is locked and communicating does the driver get the green light. The easiest way to picture it is a pit stop combined with a vending machine. The pit stop part is the speed and choreography. The vending machine part is the inventory waiting inside. But instead of dropping a drink into a tray, the machine is handling a battery pack heavy enough to change the balance of the entire car. That is why the latest stations matter. NIO's Power Swap Station 4.0 is the version that makes the visual threat sharper. NIO has described this generation with a swap time around 144 seconds and a larger internal battery inventory than earlier stations, turning the station from a clever demonstration into a small automated battery warehouse. The number matters because 144 seconds is not EV charging language. It is gas station language. A driver can watch the screen, feel the car shift slightly, and leave with a different battery in roughly the time it takes many gasoline drivers to fill a large SUV. That is the psychological break. For years, fast charging asked drivers to accept a trade. The EV was quieter, cheaper to run, and cleaner at the tailpipe, but the refill was slower. Swapping attacks the trade directly. It does not say the cable is finally fast enough. It says the cable does not have to touch your car during the stop. And once the viewer understands the machine, the bigger question becomes harder. For Detroit, Toyota, and the gas station industry, why can China build a network around this while most Western automakers walked away? The first answer is standardization. A battery swap station only works if the car was designed for it from the beginning. The pack needs a common shape. The underside of the vehicle needs access points. The mounting hardware needs to be reachable by machines. The software needs to identify the pack, verify its health, and accept a swap without confusing the vehicle. This is not the same as putting fuel into any gasoline car. Gasoline is a liquid standard. The nozzle fits because the energy product is simple to move. Batteries are physical objects with size, chemistry, cooling, voltage, weight, and structural requirements. If every automaker builds every pack in a different shape, a swap station becomes useless outside one brand. That is where NIO made a hard choice. Its vehicles were built around swappable packs.
Models such as the ES6, ET5, ET7, and ET9 are not ordinary EVs with a clever trick added later. They belong to a system where the car can release its pack from below and accept another one from the network. That requirement affects engineering before the vehicle ever reaches the buyer. It also affects the price conversation. NIO pushed battery as a service as a business model. The basic idea is to separate the vehicle from the most expensive energy component. A buyer can purchase the car while subscribing to the battery, lowering the upfront price and turning battery access into a service. The driver is no longer locked to one pack for the life of the vehicle in the same emotional way. For a household, that changes the question. Instead of asking whether a used EV battery will still be healthy in 8 years, the driver can think of the battery as part of a managed pool. The station inspects packs repeatedly. The company can monitor state of health. A weak pack can be pulled from service instead of hiding under one owner's car until resale day. The analogy is simple. It is closer to propane tank exchange than phone charging. You do not stand at the store waiting for your exact tank to refill. You hand over the empty one and take a full one that meets the system standard. That sounds ordinary. In cars, it is a major industrial decision. Western automakers mostly chose pack diversity. Each brand optimized its own platform. Some used structural packs, some changed shapes across models. Some locked the battery into the body as part of the vehicle's stiffness. That can improve cost, performance, and packaging, but it makes automated swapping much harder. Tesla proved how hard the shift is. Tesla demonstrated battery swapping years ago and even tested the idea. But the company's real network became supercharging. That decision made sense for Tesla. The company could build fast chargers more easily than redesign the entire ownership model around shared packs. It also controlled enough of the charging experience to make cables acceptable for many drivers. But NIO kept going in the other direction. China's advantage is not one station. It is the ability to align vehicles, software, real estate, energy infrastructure, and industrial policy around the same practical habit. Dense cities create many drivers without private garages. Long expressway corridors create visible road trip pressure. Domestic EV competition creates a reason to offer something that feels different from another faster plug. Then NIO expanded the idea beyond its main brand. Onvo, NIO's mass-market brand, brings the swap logic closer to price-sensitive buyers. That matters because a technology that stays in premium vehicles can be dismissed as luxury convenience. A technology that moves into family-priced cars becomes a threat to the refill model itself. NIO has also announced cooperation with companies such as Changan, Geely, JAC, and Chery around battery swap standards and network access. Those partnerships matter because swapping cannot become a broader habit if every company builds a private island. It needs a shared language. Gasoline already has that language. A Ford, a Toyota, a Chevrolet, and a Mercedes can all use the same fuel pump. The pump does not care about the badge. For swapping to pressure gas stations at scale, EVs need something similar. Enough compatible vehicles, enough station inventory, and enough confidence that the pack waiting inside the box will work. That is the part incumbents struggle to copy quickly. It is not enough to build one automated station in California or Germany and call the problem solved. The automaker has to design cars for removal from underneath. The pack supplier has to support shared dimensions. Dealers have to explain battery leasing. Insurers and finance companies have to understand ownership. Drivers have to accept that the battery in the car today may not be the same one tomorrow. That is a cultural change wrapped inside an engineering change. The theory would be interesting by itself, but the threat to gas stations begins when these stations stop looking like showroom tricks and start handling holiday traffic. That is where the numbers become difficult to ignore. By 2026, NIO reported more than 100 million cumulative battery swaps. The company's network had grown to thousands of stations in China, with heavy emphasis on urban centers and expressway coverage. Those numbers do not mean every Chinese EV driver is swapping. They mean the habit has crossed from demonstration into repeated public use. A machine can impress people once. A network has to work on bad days. China's travel calendar supplies those bad days. During major holidays, roads fill with families crossing provinces. Cities empty into expressways, and energy stops become stress tests. A charging network can look strong on an ordinary Tuesday and weak when millions of drivers move at once. That is why the 2026 May Day travel period matters. NIO reported more than 1 million battery swaps during that week, with a peak day above 170,000 swaps. Those are not laboratory cycles. Those are drivers using the system during one of the hardest periods for any refill network.
Picture what that means on the ground. A line of cars approaches an expressway service area. Some drivers go to chargers, some go to fuel pumps. A NIO driver books or enters the swap flow, rolls into the station, waits inside the vehicle while the pack is exchanged, and leaves without needing to occupy a high-power charger for half an hour. That does not eliminate all waiting. A popular station can still form a line. A station can still run short of the right inventory if demand surges. But the service rhythm is different. The vehicle bay is occupied for minutes, not for an entire charging session. Throughput is the quiet weapon. A gas station survives on throughput. How many vehicles can arrive, refill, pay, and leave per hour? A charger competes poorly if each car sits there for 30 minutes. A swap station competes differently because each stop can be closer to the time rhythm drivers already know. The station also moves the charging away from the driver. Inside the swap site, depleted packs can be charged after removal. They do not all need to receive maximum power at the exact moment drivers arrive. The station can manage inventory like a small warehouse. Packs come in low, charge inside, and wait for another vehicle. That gives the energy operator more control. Instead of hundreds of drivers plugging in whenever they happen to stop, a swap network can charge stored batteries according to pricing, grid load, battery temperature, and station demand. In plain language, it is like preparing meals before the lunch rush, instead of cooking every plate only after the customer reaches the counter. The driver sees speed, the grid sees scheduling. That combination is why battery swapping is bigger than convenience. It connects the car business to the energy business. The station is not simply a charger with walls. It is a node that stores batteries, tests batteries, charges batteries, and decides which pack goes into which vehicle. For battery health, that creates a different inspection cycle. A privately owned EV battery may go years with limited physical access. Software can monitor it, but the pack stays sealed inside one car. In a swap system, packs repeatedly return to controlled stations. The operator can track temperature history, charge cycles, capacity, and faults across a fleet. That is valuable data. It also supports a feature gasoline cannot copy: temporary battery sizing. A driver who normally uses a smaller pack for city driving could rent a larger pack for a long trip, if the vehicle and service plan allow it. That changes the old EV buying fear. You may not need to pay for maximum range every day if you can borrow extra range when the trip demands it. For household economics, that is important. American drivers often buy more vehicle than they need because they fear the rare hard day. The pickup for one annual move. The 3-row SUV for occasional guests. The giant battery for 2 road trips a year. Swapping offers a different thought. Own or lease the daily setup, then access the bigger energy pack when necessary. That does not make every EV cheap. It does change where the money sits. The threat to gas stations is not that every station disappears. The threat is that the most profitable old habit starts to fracture. If drivers can get a fast refill without gasoline, then the convenience store, the pump island, the oil logistics, and the location advantage face a new competitor. China's oil and energy companies appear to understand this. Across China, traditional fuel sites have increasingly added EV charging, And in some cases, battery swap or heavy vehicle swap infrastructure has appeared near existing energy locations. That is the practical signal. The old fuel industry is not waiting for a perfect debate. It is trying to stay attached to the refill habit. Because the real asset is not only the fuel, it is the stop. A service area has land, power access, road visibility, restrooms, food, traffic flow, and consumer habit. If the product changes from gasoline to electrons, the best locations still matter. Battery swapping gives those sites a way to sell speed again, even when the vehicle no longer burns fuel. This is where the concession matters. Swapping is expensive. A station with robotic equipment, battery inventory, grid connection, safety systems, and real estate costs far more than a basic charger. It needs compatible vehicles, it needs battery standards, it needs enough daily volume to justify packs sitting inside the building instead of inside cars. The United States is a much harder fit. American cities are spread out. Automaker cooperation is limited. Battery pack designs vary widely. Many EV buyers own homes and can charge overnight, reducing the pressure for a swap network.
A driver in Texas, Ohio, or Arizona may ask a fair question. Why build a robotic battery warehouse when a fast charger and a home plug cover most needs? That question is valid. Swapping will not replace every charger. It will not make gasoline vanish in one leap. It may remain strongest in dense cities, taxi fleets, ride-hailing vehicles, expressway corridors, and brands that control their own battery designs. It is a system with real barriers. But those barriers do not erase the shift. China has changed what an EV refill can look like. The old assumption said electric drivers had to wait while the car charged. NIO station says the car can trade the pack and move on. Return to the opening image. The EV rolls into a station. The driver stays inside. The floor aligns the car. A depleted battery drops away from underneath. A charged one rises into place. In minutes, the car leaves with a fresh energy source, and the gas station's strongest argument looks less secure than it did before. That is the real threat. It is bigger than one NIO station, bigger than one premium sedan, bigger than one company's battery service plan. The threat is the idea that charging does not have to mean standing beside a cable while the clock runs. For years, the EV promise sounded like this. Charging will become fast enough someday. Better cables, better batteries, better cooling, higher power, shorter waits. Battery swapping makes a different promise. The driver never has to own the waiting problem. That sentence changes the competition. Gas stations are not terrified by electric cars because they are quiet or high-tech. They are threatened when electric cars can match the one behavior drivers still trust gasoline to provide. Pull in, refill, leave. Legacy automakers have to pay attention because the vehicle is no longer the only product. The product is the car plus the energy network plus the refill habit. If the car is excellent, but the refill experience feels uncertain, the old fuel model keeps emotional power. That is why US charging anxiety remains so stubborn. Many Americans do not hate electric cars, they hate uncertainty. They hate waiting at a broken charger. They hate wondering whether a road trip will depend on one available stall behind a shopping center. They hate feeling that the vehicle is smart, but the refill system is fragile. Battery swapping attacks that feeling directly. It gives the driver a visible mechanical answer. The machine takes the empty pack, the machine gives back a full one. The station absorbs the complexity behind the wall. Maybe the United States never copies NIO's model at full scale. Maybe fast charging wins in most places. Maybe automakers decide pack standardization costs too much freedom. Those are serious possibilities. But China has already proved a different habit can exist. And once drivers see an EV refill that feels closer to gasoline speed than charging speed, the old excuse gets weaker. The question changes from, can EV charging ever catch up, to, what if the driver does not have to charge at all? Future Shift Report tracks the real machines and systems that make old assumptions look outdated before most people notice. Battery swapping is exactly that kind of shift. Mechanical, visible, expensive, imperfect, and already moving through China at a scale large enough to make the old refill business pay attention.
If you want more proof-led breakdowns of future technology already moving in China, hit like, subscribe, and turn on notifications so you do not miss the next report. And here is the practical question. If battery swapping became available on American highways, would you trust it over fast charging, or would you still rather stop at a familiar gas station model until the system had proved itself for years?